All right, welcome. So, you've got this powerful Kubernetes cluster, and of course, the business wants to maximize its value. That means hosting multiple teams, different projects, maybe even clients, all on that one cluster. And right away, you're faced with a critical architectural challenge. How do you share resources without it turning into a security disaster? Well, let's build a blueprint to solve that.
This really is the fundamental question, isn't it? How do we share resources efficiently without letting one tenant's mistake, or worse, a malicious actor, impact everyone else? This isn't just about some technical configuration. It's a core architectural decision that can literally make or break your entire platform.
So to answer that, we're going to build out an architect's blueprint together. We'll kick things off by really defining the challenge, then we'll architect the boundaries, enforce the rules, and finally pull it all together into a secure by default blueprint you can actually use.
Okay, let's start with the core conflict. On one hand, you've got this amazing promise of huge cost savings and super easy centralized management from a shared cluster. But on the other hand, you have the absolute non-negotiable need for ironclad security and isolation between your tenants.
The best way to wrap your head around this is to imagine your Kubernetes cluster as a high-end apartment building. And you're the architect. Each tenant gets their own apartment, sure, but they're all sharing the same foundation, the same plumbing, the same electricity. Your job is to make sure nobody can break into their neighbor's apartment or, hog all the building's hot water.
And here we see that essential trade-off in black and white. A shared cluster? Incredibly efficient, but it comes with the risk of noisy neighbors, that one tenant whose app just devours all the CPU and slows everyone else down. And then there's the security risk. A breach in one apartment could spread to others. On the flip side, giving everyone their own cluster is way more secure, but the operational overhead is just massive. So multi-tenancy is all about trying to get the best of both worlds.
To actually achieve that best of both worlds, we have to architect strong boundaries. This is where we lay the foundation for our secure apartment building. So let's look at the essential tools in your toolkit. These are your 4 pillars. Think of them like this. Namespaces, those are the walls and floors of each apartment. Network policies, they're the locks on the doors and the rules about who can even walk down the hallways. Pod security controls are kind of like the building codes. What are tenants allowed to do inside their apartment? And finally, resource quotas, well, those are the utility meters, making sure no one uses more than their fair share of power and water.
Let's start with the most fundamental tool of all, the namespace. This is basically the blueprint for an individual apartment. It creates a logically isolated space inside the cluster where all of a tenant's stuff is going to live. It's the first, and honestly, the most critical boundary you're going to establish.
So what does a namespace actually isolate? Well, what's really crucial here is that it stops one tenant from accidentally deleting or messing with another tenant's service just because they both happen to name it database. It does this by keeping all their core components, their pods, services, secrets, you name it, separate and contained within their own little logical bubble.
Okay, so we've built the walls with namespaces, but what about the hallways and all the network cables connecting the apartments? That's where network policies come in. They are, quite simply, a firewall for your pods. You can create rules that say something like, pods in tenant A's namespace can only talk to other pods in their own namespace and absolutely nothing else. This is exactly how you prevent cross-tenant attacks.
So we've architected the boundaries, but that's not enough, right? Now we need to enforce rules within those boundaries. This is all about governance. We're shifting from just physical separation to actual behavioral control.
This table really shows the two sides of that coin. Pod security is all about safety. It stops tenants from doing dangerous things, like running a privileged container that could escape its little box and try to take over the whole server. Resource quotas, on the other hand, they're all about fairness. This is what stops that noisy neighbor we talked about from hogging all the CPU and memory. It ensures predictable performance for everyone else in the building.
And the key takeaway here is that these controls are layered. You don't just pick one. You start with the namespace, then you lock down the network with policies, you enforce safe behavior with pod security, and you guarantee fair resources with quotas. You see, each step builds on the last to create a truly secure tenant environment.
All right, we've covered the theory. Now, let's put it all together into an actionable blueprint that you, the architect, can enforce by default for every new tenant that comes on board. This is it. This is your blueprint for default security. First, a unique namespace for every tenant, no exceptions. This is your foundational boundary. Second, a default deny network policy because it's always safer to explicitly permit traffic than to forget to block it. Third, enforce the baseline PodSecurity standard. This will prevent the most common container breakout attempts. Fourth, set sensible resource quotas from day one to ensure fairness. And finally, scope all permissions tightly to that user's namespace. This limits the blast radius if an account ever gets compromised. This blueprint is your secure starting point for every single tenant.
And that really brings it all home, doesn't it? Proactive security design is everything. You don't build the apartment building and then just ask people to be nice. No, you design it from the ground up with security and fairness built right into its very architecture.
So now you have a blueprint for secure multi-tenancy. But as we all know, technology never stands still. This provides a really powerful, secure foundation for today. But the real question is, how are you going to evolve it to meet the security challenges of tomorrow? Thanks for tuning in.